Okay, so we're going to look at a word problem today, and we're going to answer the question using some different methods to find equivalent fractions. Okay, it says Andy has a dozen eggs. Well, let's start there. Actually, let's read through it. It's our 3-read strategy. What are we reading for the first time? What's going on in the story, right? Andy has a dozen eggs. He uses 5/12 of the eggs for breakfast and he uses 3/12 of the eggs for making a batch of cookies. What fraction of the eggs did Andy use? So what is he doing here? He's got eggs. He's making and he's using eggs to make breakfast and cookies. Okay, let's read it again. Andy has a dozen eggs. He uses 5/12 for breakfast, 3/12 for making a batch of cookies. What fraction did he use? All right, so what are our mathy details here?
He used 12.
All right, y'all are telling me he has 12 eggs. How do you know that?
Because it says dozen.
Dozen is 12, so he has 12 eggs. Okay. All right, what else do I know?
That he has 5/12 of the eggs for breakfast and 3/12
5/12 for breakfast, okay. 3/12 for the
batch of cookies.
cookies. And we want to, all right, then what's our question?
What fraction of the eggs did Andy use?
What fraction of the eggs did Andy use? All right, so let's think about this. He's got 12 eggs, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 there, right? What fraction did he use for breakfast? 5/12. That's breakfast. So breakfast, 1, 2, 3, 4, 5. All right, and then how many do you use for cookies? 3. 1, 2, 3. So how many cookies or how many eggs did he use? Let's count. 3, 4, 5, 6, 7, 8. So what's our fraction of eggs he used? 8/12. Good. Now look at your answer choices. What do you notice?
That they don't have
8/12 is not up there. Look at me. Guess what? You're at the point now that they're not going to give you the direct answer. If your answer that you figured up is not in your answer choice, guess what? You're going to have to find an equivalent fraction. So we got to look at these and see which one we think is equivalent.
to that one.
Okay? To 8/12. So there's a couple different ways I showed you, right? We can use a model. We can use a number line. Then I'm also going to show you how to use the graph paper in just a second. Okay? First thing I want to think about, though, is there's some in here that don't make sense. Remember us talking about the reasonableness of our answers? Look at 8/12. Is that closer to 0, to half, or closer to a whole? It's closer to a whole than it is to a, well, yes. Is it close to 0? No. Is there one of these, do you think, the answer choices that's closest to 0? That's close to 0 that it probably can't be the right answer? Yeah, 1/4 is really close to 0 on a number line. So I don't think that's going to be it. So I'm going to go ahead and eliminate that because I don't want to draw out all of these fractions. That's a lot of work, right? Is there another one you think I could eliminate? 2/6. That's only, excuse me, that's only 2 out of 6. So that's probably not going to be it. Is there another one you think doesn't make sense? A, you're telling me A is equivalent to a half? Yeah, because 2 is half of 4, so that knows that that's equivalent to 1/2. Is this equivalent to a half? What's half of 12? 6. So this is going to be More than a half. So do you think it could be A?
No.
So more than likely it's going to be what?
D.
But remember how in reading we have to prove our answer?
Yeah.
Well, we do the same thing for math. We got to prove this. So let me show you the 3 ways you can prove this. The first thing is drawing a model. Here's how I draw my model with comparing fractions. What did I tell you? When we compare or we're finding equivalent fractions, our models have to be the same. No, not the same thing, the same size. Let me show you how I do this. I take a rectangle and I draw a big rectangle. Do you see that? And I split it in half. Are they the same size? For as much as my humanly hand can draw an equivalent. Okay? Okay? Alright, so I've got 8/12. That's how much I have, right? What did you guys think it's equivalent to? 2/3. Now let's stop and think. You think 2/3 is equivalent to 8/12. Are thirds and twelfths related fractions? Yes, because can I multiply 3 by a number and get 12?
Yes. 4.
So here's the cool thing. You ready? If they're related, I'm going to start with 2/3. Because I can take both and separate them into thirds. Do you see how I just did that? I have thirds down here. But up here I need twelfths. What do you think I could do to these boxes to get twelfths? How many would need to go in each box to make twelfths? Let me show you. If I half each one, what do I have now? How many parts do I have here? 6, but I need 12. So what do you think I need to do to each of those boxes now? Split them into half. It also helps us with making them equal. Do you see how I did that? Now, do I have twelfths?
Yes.
Do I have thirds?
Yes.
All right, let's draw our model and see if they're right. You ready? 1, 2, 3, 4, 5, 6, 7, 8. There's 8/12. Now the bottom one I'm shading what? 2/3. 1/3. 2/3. Are they equivalent?
Yes.
Is the same amount shaded on both? Yes. So there is a way to show the model 8/12 and 2/3. Okay. I also told you you could do a number line, right? Let me show you that. Here's how I do my number line. It's very similar to this. Both of these are within a hole, right? Okay. So I'm going to do 8/12 on top and 2/3 on the bottom. Now you told me twelfths and thirds are related, right? So I'm going to start with thirds. Here's thirds. Okay. So here's 0/3, 1/3, 2/3, 3/3. Do you see that? I'm going to take the same process up here, and I'm going to take my thirds, split them, and that makes what? 6. And then split them again, and that makes what? 8s. So this is 0. I'm sorry, not 12ths. Sorry. 0/12, 1/12, 2/12, 3/12, 4/12, 5/12, 6/12, 7/12, 8/12, 9/12, 10/12, 11/12, and 12/12. So here's 8/12. Here's 2/3. Are they at the same point on a number line? So if they're at the same point on a number line, what does that prove? That they're equivalent. Okay? Now, this one's a little different. Hang on just a second, Micah. We're going to do twelfths and thirds. Okay? So I'm going to come down here and I'm going to shade, or I'm going to box in 12 boxes. Okay? Yeah. Okay. So I'm going to shade in, or box in 12 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Do you see how I did that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I want to find 2/3 equivalent. Well, that means I'm going to have to make my models the same. So I'm going to do my 12 boxes again. Do you see that? Now my 12ths, I've got to have how many?
8.
I've got to have 12ths. I'm going to show 8 12ths, but I got how many? But here I need 2/3. How many boxes do you think are going to need to go if I'm going to show 2/3?
3.
If I do 3 boxes, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, that gives me 4 boxes. I only need 3 boxes. How many of these squares do I need to do to separate? Think, guys, I've got 12 boxes. Yeah. 12 boxes. I need to split them in how many parts? Now, listen. I've got 12 boxes. How many parts do I need? 3. So I'm going to put 4 in a box. 1, 2, 3, 4. There's a third. 1, 2, 3, 4. There's a third. 1, 2, 3, 4. Do you see how I did that?
Yep.
Now let's shade. 1, 2, 3, 4, 5, 6, 7, 8. 2/3. Here's a third. Here's a third. What do you notice? So I proved using 3 different ways of how to show that 8/12 is 2 and 2/3 are equivalent. When we go to do these, you have to show and prove these one way or the other. Do you understand?